Alright, let's look at the greatest common factor of two monomials. Remember, a monomial is a single term expression. So this is a monomial, and here's another monomial. The directions say find the greatest common factor. So we're familiar with greatest common factor, or GCF, of numbers. So like, for instance, if you were asked to find the greatest common factor of 4 and 26, you could do that, right? So that's part of what we're going to do. But we're actually going to do that also with each of the other variables. So we can break this up into small little mini problems. So we've got the 4 and the 26 greatest common factor. Then we've got the u's. So we have a u to the 6th and another u to the 6th. Then we have x's, right? We've got an x to the 3rd here and an x to the 6th. And over here we've got a w, but no w's there. So we just break it up into little pieces, and then we put the pieces together. So if we look at each of those pieces, we know that the greatest common factor of 4 and 26 is 2, right? So that's the first part of our answer. So between 4 and 26, we've got 2. Then we look at just the u's, the u to the 6th and u to the 6th. So of course you can think of this, one way that I teach greatest common factor is you can think of it like a bucket. So here we have a bucket, and here's another bucket, and each of those buckets have u to the 6th inside. So you have to ask yourself, what's the largest number of u's you can pull out of each bucket? Well, in this case, you could pull u to the 6th out of both. So the common factor is u to the 6th. Now if we had a bucket with x to the 3rd and another bucket that had x to the 6th, what's the biggest amount we could pull out of both of them? We got to pull the same amount out of each one. So we could pull an x to the 3rd. That's the most we could pull out of that. So that means that we'd have to pull an x to the 3rd out of there. Even if that leaves behind 3 x's, that's okay. So our greatest common factor of that one is x to the 3rd. And then of course there is no common factor of the w's, because there would have to be w's in both places. So this is it. We find the greatest common factor of each of the little parts, and then we put it together as our final answer, 2u to the 6th, x to the 3rd. Okay? Let's look at another example quickly. Same concept. Here we've got two monomials. We just break it up. We find the greatest common factor of 18 and 20. Find the greatest common factor of w to the 3rd and w to the 4th. Find the greatest common factor of y to the 6th and y to the 7th. And then there's no x's in common, so that can't be part of our answer. If we were to do that, we get 2 here, w to the 3rd here, and whoops, I made a mistake. This is y to the 9th, not y to the 6th. So that's going to give us y to the 7th. So our final answer is 2 w to the 3rd, y to the 7th.